the mightiest machines on the planet. Big, mean, invincible. Battling Mother Earth, the modern world couldn't survive without them. In this episode, we climb aboard maritime monsters that go where others fear to float. The world's newest drill ship is tested to its limits.
Steady now. Just hold him there.
A mighty pipe-lay vessel builds Europe's longest subsea pipeline. And the world's largest jet trencher
Rusting down.
blasts the seabed. It's time to get behind the wheels of some dirty great machines. Ensco DS6 is the world's newest drill ship. Costing £425 million, she's also expensive. Her mission is to drill for oil on the high seas. She's sailing to a testing location 2 miles off the South Korean coast. Over the next several days, she must pass critical sea trials.
Make sure everybody's on the same page. Everybody knows what's expected of them.
And most importantly, her crew must perform 3 vital tests to prove her drilling equipment is safe to strike black gold.
Hi guys, how's it all going? The next job on the program here is to lay out that riser running tool. I know some of you are new on the job here. You've all got experience doing it, but here it's a little bit different, okay? We want to try and keep it safe. There is a little bit of pressure to get it done, but we will get it done correctly. We will get it done on time, and we'll get it done on budget. An old saying, plan the work, work the plan. And that's what we're going to do.
The man tasked with putting this Leviathan through her paces is senior subsea engineer Don Breen. A 30-year oil industry veteran, he's literally the Don of deep-sea drilling.
When I started in the oil field 30 years ago, rigs like this were only dreamed about. This is state-of-the-art. The cost is enormous. The equipment, size and weights are huge.
Drill ships are mobile oil rigs, designed to reach the deepest and most inaccessible oil reserves in the world. They lower thousands of tons of drilling equipment to the seabed via a hole in the hull called a moon pool. At the end of a long pipe called a riser, a powerful drill eats through Earth's toughest rocks. If oil is struck, the drill ship will make way for a production rig, which will extract the oil for market. Stage 1 of Ensco DS6's tests is to ensure that 2 23-meter, 25-ton riser sections thread together perfectly.
This is the first time we've ever picked this equipment up. We're proving the system as we go here. It could be dangerous if it gets out of control.
At a cost of £200,000 each, the risers must be carefully lifted into a vertical position. A trolley takes the first to where Don and his team are waiting.
Come on in.
Lifting weight equivalent to nearly 2 double-decker buses is dangerous work. So safety on board Ensco DS6 is of paramount importance.
These pieces of equipment are very big, and they will tear up some equipment if they hit anything. The object is to keep everything under control. Never let anything go once you lift it. You have to be able to control it. Okay, steady now. Slow down, slow down. Yeah, bring him up. Tell him to watch his weight indicator.
As ENSCO DS6's hoist lifts the riser, the trolley's hydraulic arms keep it from rolling off onto the deck.
A bit more. That'll lift. Whoop, 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 whoop. Hey, hold on.
The hoist has unexpectedly shut down.
Guys, time out. Yeah, just hold him there. Don't go up anymore. Hold the driller.
It's registering a warning.
That's to stay in free will.
Don and his team must investigate.
We're still in the anti-collision mode.
The anti-collision system has stopped the hoist. They need to make sure it's safe to proceed.
You're up against us. It wasn't open, but the Olmsted valve was showing the open position. Okay. Make sure you're in free wheel. Hang on. Okay, you in free wheel? Yeah. Okay. Tell him to come down easy.
Don and his team decide it's safe to continue.
Well, we should be right to come in now. Pick up on the driller, just a tad. Steady, but it's got to clear the handrail. We want to try and get that up as tall as you can, okay? Yeah, that's good, nice and tall. Okay, now you can come back on it. That's good, man. Okay, get him to release the arm.
The riser is vertical. Now the team must thread it through the drill floor.
Come down easy on the driller. Oh, down a little bit more than... Okay. A bit quicker. Keep going. A bit more. Okay.
It's taken 4 hours to install the first 23-meter-long riser. As dusk falls, Don's team start installing the second.
Yeah, go ahead. Yeah, as soon as he gets that out of the way.
It's almost there right now.
Yes. Keep going. Let's go all the way. Keep
all the way up?
All the way up.
Okay, I'm good there.
1 hour later,
we're good here, okay.
They finally thread the risers together.
We're pretty much finished on the floor here for a little bit, okay? All right. Actually went really well. It progressed quite smoothly. The equipment worked well, the hands worked well. We got it in, landed safely, no problems.
Stage 1 is complete, right on schedule. But Stage 2 will be an even greater challenge.
We've got a drop-in piece that fits here, then we can move this BOP into there.
Lifting a 5-story tall, 420-ton chunk of iron, whilst this maritime marvel is at the mercy of the sea.
If you dropped it, I sure wouldn't want to make that phone call.
Two miles off the South Korean coast, the world's newest drill ship, ENSCO DS6, is being put through her paces.
Steady, steady. Down on the driller.
It's up to Dawn Breen's team to ensure she passes a series of critical tests and safety checks to prove she's ready to drill for oil.
Are we down?
Maybe down the way.
There you go. Okay, good. Systems are big and complex. The equipment weight and size is huge. It's crucial that we get this right here. We have to have it well back.
ENSCO DS6's vital statistics are off the scale. Her giant hoist can lift close to 1,000 tons. That's the same weight as 15 battle tanks. A 3,000-meter riser pipeline is about the height of 7 Empire State Buildings. Inside, a drill pipe cuts through rock to a depth of 12,000 meters. That's 40,000 feet, the same distance as an airliner flies above the ground. And at 425 million pounds, she'd put a dent in even Roman Abramovich's wallet. ENSCO DS6's tests are the finale of a 4-year project to build the state-of-the-art drill ship. And it all started here. Samsung Heavy Industries' 1,000-acre mega factory in South Korea. It's a miniature city created to build monster maritime machines, manned by 30,000 engineers and skilled workers. One of them is Young-sik Chung.
저희 삼성중공업은 100만 제곱미터의 대지 위에 설계와 생산 시설이 같이 구성되어 있습니다. 각 부서관이 정확하고 효율적인 업무 구성을 통하여 모든 일이 유기적으로 구성될 수 있도록 진행되고 있습니다.
A ship like ENSCO DS6 starts life as thick steel plates. Robotic oxyacetylene torches divide them into thousands of different components. As they advance down the production line, they're joined together to grow into ever larger ship sections. Finally, the world's largest floating cranes connect 9 massive sections to make up a complete ship. After 3 years of planning and 1 in construction, ENSCO DS6 was born. Two miles out to sea, Don's team have already completed the first major test, the installation of a pair of 23-meter-long risers.
We've got a drop-in piece that fits here. Then we can move this BOP into there.
For test stage 2, they must lift and place the blowout preventer, or BOP, onto a trolley that'll position it under the risers. At 5 stories tall, and with a £20 million price tag, it's the largest and most expensive piece of kit on board ENSCO DS6. But it's a vital piece of safety equipment for managing risks associated with offshore drilling.
BOP is a critical part of the operation. No BOP, no drilling. If you lost control of the well, you'd have no way of stopping it. You'd have an environmental disaster.
Connecting the riser to the oil well, the BOP ensures safe drilling and environmental protection. In the case of an emergency, rams inside the BOP shear the pipe and seal the well, preventing oil from rising to the surface. Its critical ENSCO DS6 proves she can deploy this vital piece of safety equipment. But moving steel this large is a mammoth challenge.
BOP is 420 tons. As you can imagine, moving this thing around, you definitely don't want it to get loose. You must keep control of it. You cannot lose control of it. If you did, and you dropped it, and it went into the water, and I sure wouldn't want to make that phone call. we're okay in the moon pool, mate. Come on down.
John, Greg, and moon pool, we're coming on up.
The hoist lifts the BOP from its storage area.
So keep coming forward, a bit more. Together, together. Try and bring it forward a tad more. So far, so good. Hey, Jeff, come on down.
The BOP is lowered onto its trolley.
Okay, hold it. What we'll do is we'll just nudge it. You know how to operate the pins? BOP will come down and land out on these pins. That takes the whole weight of the BOP. And then we can release the BOP. And then the BOP is captured into the trolley. Look like they're fully engaged. We still got a bit more to come down, mate.
But Don spots a problem.
To me, it looks like it's on a slight angle. So the only way it can do that is if, you know, on the end of the pin, with that raised edge, if it's sitting up on one of them.
The BOP is leaning.
We better find out because we're going to do a load test.
If the BOP topples over, 20 million pounds worth of equipment goes to a watery grave. And Don's phone call nightmare will come true.
Okay, go down and have a look at each one, okay? See if you can see the pin sticking all the way through, okay?
So Don sends down an engineer to investigate. Like a human endoscope, he must photograph the locking pins down in the BOP's belly.
This is the first time we sat it in there, so we need to just confirm that everything is correct. They'll measure it up now and come back with an answer here in a minute. What's the verdict? Engaged, yeah. That's okay. That's okay. They're all engaged.
The BOP is secure.
We checked it out and everything's okay. We went down and inspected the pins, no problem. So we got it landed.
The drama's over and the tests can safely continue. Elsewhere in South Korean waters, a different maritime monster is preparing for battle. UT-1 is one of the world's largest remotely operated vehicles. 10 million pounds worth of engineering, it's designed to bury underwater cables and pipelines in trenches cut into the seabed. With clients demanding it must be working within the next 5 hours, UT-1's crew are battling to complete checks and get the machine into the sea before time runs out.
Yeah.
Okay, if we can start to lower the TSS frame, thanks.
Okay, lowering tracker flame.
Keep it coming. And all stop.
The man in charge of this beast is the chief super, Greg Bush.
UT-1 is the world's largest, most powerful, free-swimming, remotely operated jetting trencher. If you want your product buried quicker, deeper, first go, UT-1's the vehicle to use.
Jet trenchers are giant submersibles launched from surface ships. They descend into the depths where their mighty water cannons, called jet legs, blast the seabed. Creating trenches of up to 10 feet deep, undersea pipes and cables are swallowed up and protected. UT1's mission is to bury a 60-mile-long undersea electricity cable between the South Korean islands of Jeju and Jindo. The cable has already been laid on the seabed along a geologically suitable route and must now be buried to protect it from ocean currents and fishing boats.
Okay, pants up one.
Yep.
To find its target underwater, UT1 boasts an array of high-tech electronic eyes.
We've got these two cameras here, a colour and a black and white. We've got a rear-facing black and white, and we've got another camera down aft. So we can go down to even one camera and we can continue operating. Having said that, it's good to have them all operating. Gives the guys extra confidence. It's far better when you can see what you're doing.
To maneuver the 60-ton UT1 underwater with pinpoint accuracy, the machine is equipped with powerful propulsion.
Yeah, okay, and we'll do the forward thrusters come off your port motor.
Okay, stand by.
There you go. Okay, we're underway. Give it a little bit more tickle. UT1's got 10 thrusters on board. We've got 4 vectored horizontal thrusters. We've got 4 vertical thrusters. And we've got 2 what we call big dogs. And they're our main propulsion when we're jetting. There we go, that's underway. Give it a bit more. Okay, and stop that.
Okay, do you want to go to jet legs?
Seeing and swimming underwater are crucial, but UT1's most important component is its jet legs. No jet legs, no trenching.
Okay, now close that port one now.
Port leg.
This is the business end of UT1. Everything else on the vehicle, the electronics, the lights, are all about getting these 2 things down into the seabed.
3 meters long with a combined weight of 1.5 tons, UT1's jet legs are designed for one purpose: blasting the seabed into submission.
The 4 water pumps that we have here can deliver roughly 5,000 cubic metres of water an hour, which is equivalent to filling up 2 Olympic-sized swimming pools in 1 hour. All that water is delivered through this pipework system into the jet legs and out through the jet nozzles into the seabed, creating a large trench up to 3 metres deep that the product will settle down to the bottom of. All stop. Okay, that's good. If we can have starboard jet leg tilt forward.
After thorough pre-dive checks, Greg gives UT1 a clean bill of health.
Yeah, that's good. Cheers, thanks.
Now just 3 hours remain before the trenching deadline. It's time to launch. But this part of the operation shivers the timbers of even the saltiest sea dog.
We've got large, high tension voltages, we've got large loads, 70 tonnes swinging on a lift wire. So we've got to make sure that everybody is up to the job. Throw in 10-metre seas and it can become quite emotional at times.
To avoid being reduced to tears, Greg needs a textbook deployment. But it's just not going to be his day.
Thrusting down.
As a mysterious underwater object threatens to jeopardize the entire mission.
We don't know what it is. We roughly know the size of it. It could be anything.
"100 miles off the South Korean coast, a giant submersible, UT1, is about to be launched. Within the next 2 hours, the machine must be underwater and burying a pre-laid electricity cable between the South Korean islands of Jeju and Jindo. The clock's ticking for Chief Greg Bush and his team.
Operating UT1 on this project, we have about 6 clients on board that all want to get the job done. Time is money, as everybody knows, so there's a bit of pressure that we get to make sure that we're achieving the highest speeds and the highest depth of burial first time.
Greg and his second-in-command, John, take up their positions in UT-1's control room.
Okay.
Can you start the cursor, please?
Launch stage 1 is to pick up the machine with a giant A-frame crane
Pick it up.
and suspend it over the sea.
That's UT-1 off deck. I'm just going to start booming out.
Greg carefully guides the A-frame via joystick controls.
You want to just knock your cursor off for now?
Now comes stage 2, deploying UT-1 into the water. But this is the riskiest part of the operation. There's a danger the sea's motion could damage the umbilical cable containing the machine's power and communication supply.
We have to make sure that we get our launching sequence spot on so that we get a nice, smooth transition through the splash zone in all sea states. I'm going to start lowering you down.
The sea is getting choppy, making a clean deployment harder by the minute.
Okay, you're on the move. It's not, just seeing if it chatters. Just getting ready. I want to refit that umbilical now. Okay, mate, that's constant tension.
Waves finally lap over the top of UT-1 and it descends into the deep.
Okay, that's 10 metres below the surface. Good job, guys.
Now en route, it won't be long before UT-1 can bring its might to bear on the South Korean seabed. It weighs 60 tons, the same as 50 average-sized family cars. It can descend nearly a mile underwater where the pressure crushes steel. The jet-leg water cannons are 35 times more powerful than a fire hose, burying the largest cables in trenches up to 3 meters deep.
That's motor 1 running and got boost pressure.
In UT-1's control room, pilot Kent Warbrick flies the machine down to the ocean floor.
Thrusting down. 40%. That's UT-1 on the way to the seabed.
His mission is to find the electricity cable 40 meters below and blast it into a trench. He deftly maneuvers UT-1 via joysticks, controlling the machine's thrusters.
All stop on the downs. 33 meters.
But a nighttime launch makes flying UT-1 doubly hard.
When you are flying a UT-1 to the seabed in the dark, when there's no visibility, it's actually more or less like flying in a helicopter in the dark and try to land it. 4 meters to go.
UT-1 must be trenching within the hour to stay on schedule. And with an operating cost of over £65,000 a day, the client is breathing down Kent's neck. The pressure is on.
And all stop there. That's UT-1 on the seabed.
Just see if you can play with cameras, John, see if you can get some viz on that front end.
Yeah, it is.
But there's a problem. Sonar picks up an object on the seabed. It's right on top of the cable, directly in UT-1's path. Trenching over it could damage UT-1's thrusters, immobilizing the machine. Subsea pilot Craig Smith monitors the situation.
At the moment, it's just an unidentified object. We don't know what it is. We roughly know the size of it. We don't know. It could be anything. We're going in now to get a better look at it, get an inspection, see what it is, and possibly to remove it.
Anything that could damage UT-1, no matter how large or small, must be investigated. It's a job for UT-1's little brother. The size of a family car, this remotely operated vehicle, or ROV, sports manipulators to remove obstructions in UT1's path. Launching it costs thousands of pounds. But it's the only way to find out for sure what's blocking UT1's path. Craig pilots the ROV down to the seabed.
Yeah, go ahead. Yeah, we lost a bit of viz there, but we passed over the object. I didn't see any targets on the sonar and nothing visually. I'll just see what we can see. There we go. Bridge ROV, that seems to be the object right in front of us.
Yeah, copy that. Does it actually look like a boulder to you, or you can't really tell at the moment?
It looks like a welly.
Take it?
Yeah, give it a grab. There you go, Bridge. Das Boot.
The ROV recovers Das Boot and brings it back to the surface.
Yeah, this is the first Wellington I've brought up, but I'm sure there's plenty more down there.
Thousands of pounds seems a lot to spend on one Wellington boot. But it's small change compared to the cost of repairing the £10 million UT1 and any potential damage to the client's cable. With the obstruction removed, it's all systems go. Pilot Kent deploys the machine's jet legs. They blast the seabed with 1.4 tons of water per second. The cable starts disappearing into the trench. UT1 has met the deadline, much to the relief of team boss Greg.
We're down on the seabed now. We're trucking along, trenching. So from now on, it's just full steam ahead.
With UT1 up and trenching, South Korea's undersea cable will soon be buried and the country's power supplies secure. UT1 may be the ultimate machine for burying cable and pipes, but to lay them in the first place, you need another maritime monster. Castoro 6 is a floating factory. She houses a production line that joins and welds pipe sections and feeds them out of her stern onto the seabed as a complete gas pipeline. On average, she can lay 2 miles of pipe per day. And ensuring this is project director Leandro Menicelli.
Castoro 6 was specifically designed and built for pipe lay. There are only 3 or 4 vessels like Castoro 6 in the world. We have laid 8,000 kilometers in every continent in the world.
Right now, Castoro 6 is in the Baltic Sea. Her mission is to lay 70% of the Nord Stream project, a 750-mile double undersea pipeline that'll guarantee gas supplies from Siberia to Europe.
Nord Stream project is a huge project, probably the biggest pipe-lay project ever performed in the world. The schedule is very challenging, and we plan to complete both pipelines in October 2012.
To meet the deadline, her crew of 330 engineers operate an ingenious onboard factory that runs with military precision.
The first phase of the operation is to supply pipes to Castoro 6. We supply pipes by ships in single joints 12 meters long. The pipes are assembled and welded in double joints. They are welded together in a continuous pipeline string. Before the joints enter the water, they have to be checked so that the weld is certified to be good.
Each ultra-strong weld is then sealed with a corrosion-resistant sleeve. Finally, the connected pipes run down the ship's stinger into the Baltic Sea and touch down onto the seabed.
We believe that Castoro 6 is the future of the pipe-lay installation. It is a very stable, very efficient and productive. Nothing compares to Castoro 6 when a long pipeline has to be installed.
Thanks to Castoro 6, the Nord Stream project is on course for completion by autumn 2012. And Europe will get its badly needed gas supplies right on time. But 5,000 miles away off the coast of South Korea, it's all hands on deck for drillship Ensko DS6. She's ready for the third and final stage of her tests. But with the sea getting rough,
this is all heavy equipment. The riser's moving around some.
there's almost £500,000 of heavy metal hanging in the balance. Drillship Ensko DS6 is 2 miles off the South Korean coast. Having already completed 2 stages of critical tests, she must now pass her final major trial to prove she's ready to drill oil on the high seas.
The way it's moving right now, I don't know if maybe they can turn the ship to get it more stable.
Her fate lies in the hands of senior subsea engineer Don Breen and his team.
The crews are under pressure to make sure that everything runs smoothly, everything is correct. If it's not, then we have to rethink it and get it correct, come back and try it again. But it has to be right.
Danny, can you possibly close them dogs a little bit and give us a little bit more centralized position?
Test stage 3 is to attach a pair of 25-ton risers to the blowout preventer, or BOP, and then deploy the whole lot into the sea through a hole in the hull called the moon pool.
It's like a big swimming pool with no bottom. You definitely don't want to fall in there.
Every sailor knows a hole in the hull means a one-way ticket to the seabed.
자, 여기 구멍이 뚫린 보트가 있습니다. 제가 무게를 주기 위해서 너트를 넣었고요. 아시다시피 이 배는 가라앉을 겁니다. 한번 보겠습니다. 예, 저희 상식대로 배는 가라앉았습니다.
But a drill ship's moon pool is ingeniously designed so the ship won't sink.
자, 이번에 구멍난 보트에 튜브를 꽂아서 구멍을 막아보겠습니다. 자, 배가 가라앉을지 한번 보겠습니다. 자, 이번엔 배가 가라앉지 않았습니다.
The sealed moon pool allows seawater to rise to the level of Ensko DS6's waterline, but without it coming aboard and sinking the ship. Before being lowered into the moon pool, the BOP and risers must be firmly bolted together. It's a job for Don's number 2, Dan Reed.
Fred, when y'all are coming across, check that side, make sure your handrails and everything can clear the baskets.
His team is working from a platform above the BOP, and they must bolt in the risers using specialist tools. It sounds simple, But Mother Nature poses a challenge. A rough sea is making 50 tons of riser sway.
You know, this is all heavy equipment. The riser's moving around some, and you know, we'll have to guide that carefully in there.
Just wanted to stabilize it a little bit, then you can open them on up.
The team's safety rests with Danny the driller, upstairs in Ensco DS6's drill house.
All right, I'll stand by. Just let me know when you're ready.
The driller controls the huge hoist carrying the pair of risers.
We'll go ahead and stand by.
It's his job to gently lower them down onto the BOP.
He's the main man on the rig floor. He is in charge. He runs the show. The driller needs to have some finesse, particularly when you're moving around equipment, 400 tons in weight. You've got to do it gently.
All right, Danny, go ahead.
Roger.
The operation begins.
A couple inch bites at a time as it moves. Down easy.
Roger, coming on down.
Using just one tiny joystick and keypad, Danny controls 50 tons of cold, hard steel.
Stop.
One slip and it drops onto the BOP, damaging this vital piece of equipment.
All right, what I want you to do is come down, sit down about 10.
All right, coming down easy with 10 on it.
Give me about 10 degrees counterclockwise.
Roger, counterclockwise.
We're pretty close on the rotation now.
How does that look, Dan?
We're in there, Han. Good work, gentlemen. I appreciate it.
After 2 hours, the BOP and risers are firmly bolted together.
All right, Danny. The only thing holding the BOP right now is you.
Now it's time for the finale, deploying the BOP and risers through the moon pool.
Just hold what you got, Mark.
Want to try to put it on up, or do you want to come on down and get the BOP wet?
Roger that, coming on down easy.
Greg, I need one more guy down there on that side watching this transporter trolley back.
All right, coming down, setting 10 on it.
The BOP and risers creep towards the water.
Coming down easy.
Roger that, coming on down easy.
Gently.
500 tons of iron splashes into the moon pool.
Get this transporter out of the way. Take it back to the park. Keep coming. Okay. I'll stop, Danny. We're gonna put a mux clamps on right here. All right. We got.
All right, buddy, I'll stop.
Mission accomplished, safely and right on schedule.
All right.
Don congratulates his team.
Well, we got it. Job well done. We got through, we didn't tear anything up. We actually did more tests than we had scheduled. And we've completed it ahead of time. So it shows that the system has worked very well. It's come together quite nicely, actually. Very happy.
Shipshape and ready for action, it won't be long before Ensco DS6 is operational and drilling for oil on the high seas. 3 maritime monsters, one mission: to find and supply the energy we need to keep our world running. Drilling the deepest oil reserves, laying and burying the longest pipes and cables, mankind's future is secure. Thank you, Dirty Great Machines.